What I'm about to demonstrate is how the naming, priority, and organic chemistry nomenclature can change based on the positioning, size, and number of different molecules. So we're going to start off with some hexanes and some cyclohexanes, and we're going to see how little changes are going to make differences. So we're going to start off by putting a methyl group on the third carbon. So this would just be a 3-methyl group. Now, assuming you would name it, you would write the group and then hexane. Now, here we have another hexane, and say we still have our methyl group, but now we have an ethyl group. Well, now we have things to consider. So we have 1, 2, 3. That's the distance from the left side for the methyl, but then 1, 2, 3, that's the distance from the right side to the ethyl. So which one do we prioritize, the ethyl or the methyl? Well, the ethyl is bigger, so we prioritize that. So this is going to be carbon 3 and this is going to be carbon 4. Now, when writing it, we have a 4-methyl and we have a 3-ethyl. Which one do we write first? Well, we're going to write it based on alphabetical order. So ethyl starts with an E. So we're gonna, an E compared to methyl, which starts with M, it comes before it in alphabetical order. So we're going to write 3-ethyl and then 4-methyl. Now watch how the priority changes when we do something different. So say we still have our methyl group, but we add a second methyl group. Now 1, 2, 3, that's the distance from the left side. 1, 2, 3, that's the distance from the right side. Now, what's the difference? Well, here we have one group, but in here we have two groups. Now, because we have two groups here instead of one, we're going to prioritize this side, and this is going to be carbon 3, and this is going to be carbon 4. So this is going to be 3, 3 to indicate for the two methyls, and then dimethyl. So that's the group for there. Now, however, even though this is di, it's a prefix that says di, and d comes before e in the alphabet, we do not consider prefixes. We're only going to consider the M on the methyl, and so therefore the 4-ethyl will come before the 3,3-dimethyl, and then we write hexane. Now, say we still have our dimethyl there, and we have our ethyl there. Now notice this, this is a heptane, this is not hexane, so it's a 7-carbon chain. Now if we add a 1, 2, 3 carbon chain over here, notice something weird. We have 1, 2, 3, 4, and then we have 5, 6, 7 if we go this way, or 5, 6, 7 if we go that way. Now, which way do we pick? Now, if we go on this route, notice that we have one side that has substituents and another side that has substituents, carbon 3 and carbon 4. However, if we go carbon 4, 5, 6, and 7 like this way, we have 1, 2, 3 carbons that have substituents. So we're going to pick this route because it has the most amount of substituents. Now, which side do we prioritize? Remember, this is 3 carbons away from the right side, this is 3 carbons away from the left side, but this one has 2 substituents, so we're going to have, this is a 3,3 dimethyl group here. So methyl starts with an M. This is a 5-ethyl, ethyl starts with an E, and this is a propyl group, and P, that starts with a P. So we're going to write 5-ethyl, and then we're going to write 3,3-dimethyl, and then we're going to have 4-propyl. And then, of course, we write heptane after that. So that just shows you that if you have two chains of equal length, you're going to pick the one that has the most amount of substituents. Now, say over here we have our cyclohexanes. We have our methyl here. How do we number that? Well, that's just going to be 1-methyl because we're just going to put number 1 at the first substituent that we find. So this is a 1-methyl group. Now, if we do the same thing, but we have an ethane group over here, ethyl group over here, we're going to prioritize the bigger groups. This is going to be carbon 1, this is going to be carbon 2. So this will be 1-ethyl based on alphabetical order, 2-methyl. Now say we have the same thing, the ethyl group there, but now we have 2 methyls, so it's a dimethyl. We're going to prioritize this carbon, so it's going to be 1, 2 that way. So we're still going to have 2-ethyl based on alphabet, and then 1, 1 dimethyl. Now say we do the same thing again, but instead of an ethyl group, we have something called an isopropyl. Now, we're still going to prioritize the dimethyl as carbon 1, this is carbon 2. Now the thing is with isopropyl, iso is not considered a prefix. So we actually consider the I, we put the I into consideration, and since I comes before the methyl, which starts with an M, we're going to put this first in the alphabet, not the P. We're not going to consider the P, we're going to consider the I, because isopropyl is the only, I repeat, isopropyl is the only prefix in which you count the first letter of it. Every other prefix like sec and tert, we do not count those. We only count for iso when we look at the I. So this is going to be 2-isopropyl, and then 1,1-dimethyl, and then cyclohexane. Sorry for the handwriting. All right, there we go. Now, say we do the same thing again, but we have a tert-butyl group. Now, tert-butyl, we're not going to consider the tert, we're going to consider the B, and B comes before M for methyl. So we're going to have carbon 1, 2, so we're going to have 2 tert-butyl, or sometimes they say T-butyl, and then you have 1,1-dimethyl, and then that's going to be a cyclohexane. Now, for this one right here, what if we had, instead of just a regular tert-butyl group, we have something that looks like this. Now this one gets a little weird. First, we're still going to prioritize this because there's 2 groups. This is going to be carbon 2. So if I write my regular old 1,1-dimethyl, right? You're going to notice that this on carbon 2, we're going to do something different. So we're going to put in parentheses the name of this substituent. So we have 1, 2, 3, 4. That's the longest chain on this substituent. And notice that on carbon 1, we have 1, 2 methyls. So what we're going to name it is a 1,1-dimethyl. Now, since this is a 4-carbon chain, usually you would call that a butane. But because it's a side group on the main chain, we're going to call it a butyl. So it's going to be 1,1-dimethyl butyl, or that's a U. And then we just close our parentheses right there, and then we write cyclohexane. So this is what they call, actually, right there, they call it as systematic naming. And when we have tert-butyl and something like isopropyl, that's considered common naming. So those are the different types of things that you can change in a molecule that will cause the priority to change, and also with the alphabetical order.